Hello everyone. Today we're going to be looking over the impulse worksheet. Now, as I said in the description, the worksheet is set up a little differently for the first two questions, where I'm really breaking down the question into all of its tiny little parts that you kind of have to consider when working on these type of questions. Now, a lot of these parts are very straightforward for getting, and I know sometimes when it's very straightforward, it can throw people off. People start thinking it's like a trick question or something like that. But let's start. So in the first one, we have a 1,000 kilogram car that's moving 20 meters per second that has an impulse of 2,000 newton seconds to the west. It's asking what the final velocity is, and that's what we're going to be solving in question E. But to start off with, we have A, which is giving us our 2,000, because that's our impulse, is 2,000 newton seconds, which means our change in momentum is also 2,000 newton seconds because impulse is equal to our change in momentum. Now, the initial momentum is 1,000, so P is equal to mv, which is equal to 1,000 times our 20 meters per second, which is 20,000 kilograms meters per second. What is the final momentum? I believe it comes to, no, it does not come to a rest. We have to figure what that is. So we know this is the starting momentum, the initial. We know that the final momentum is 2,000. The change in momentum is 2,000. So it was 20,000, and that changed by 2,000. Now, because this is going to the east and this is going to the west, that means that this change in momentum, or this impulse, ended up slowing it down or decreasing the momentum. So it's going to be the 20,000 minus the 2,000, which gives us the 18,000 kilogram meters per second. Now, how am I able to deal with that with the units? Well, it's important to know that a meter second is equal to, a Newton second is equal to a kilograms meters per second. So we get 8,000, and then eventually to find the final velocity, we just take that 18,000 and we divide it by the 1,000 of the mass of the car to give us 18, and it should keep on moving to the east. Yes, that makes sense. So basically we have a car that was moving, something hit it which slowed it down a little bit, and then it kept on moving right afterwards. In our next question, we have a cart that is moving along and is brought to rest. So what is its initial? Well, it's just P is equal to mv again, which is 1.5 times 2 meters per second, which is equal to 3 kilogram meters per second. The final momentum is 0 because it was brought to rest. So our final momentum is 0. So our change in momentum, well, it went from 3 to 0. So it's 3. And if you want to, you can make it negative. But I don't think in this one our direction matters all too much. That's our change in momentum, which is also our impulse because they're the same as each other. And so what's our force? Well, it's F net times T is equal to our impulse, which is 3 kilogram meters per second, or you can write Newton seconds here. Our force is, that's what we're looking for, I'm sorry. Our time is 0.3 seconds. It's equal to 3 kilogram meters per second, and the net force. And so we just need to divide both sides, and if we do that, I do believe we get 10 as a final answer. So that's how these momentum questions work. It's kind of a little bit of some moving pieces, but a lot of the pieces just end up being equivalent to each other, so we don't have to worry about it. Okay, so question 3 is a classic question that occurs, and a lot of people get thrown off for it. They're giving you the impulse, and they're asking you for the change in momentum. You should know that J is equal to delta P. So that impulse that they give you of 15 is also the momentum, the change in momentum from this impulse. Just, don't mess that up. Just know that they're one and the same. They might give you some extra numbers to kind of throw you off, but just keep that in mind. Okay, an airbag is used to decrease the momentum of the driver. The airbag reduces the force on the driver by safely decrease the momentum of the driver by basically increasing the length of time. That's what we talked about in the video. The longer time you have, the less the force is, because your change in momentum is the same no matter what. So if you make the time really big, it's going to make the force very tiny. That's the kind of idea that we have. Okay, next one, we have a force on a ball that is imparting an impulse, and then it's asking us to calculate the time that we have. So I would use this part of the formula, where J is our 3.6 Newton seconds. Our net force is 600 newtons times time. So I just divide both sides by 600, and if I do that, I get 0.006 seconds. Okay, next we have a golf club that is hitting a golf ball that's stationary. So that means we're starting off at rest. And we're given an average force and accelerates the ball to 44. So it was at rest, it's going to 44, and we're asking for the impulse. Now, these are the other type of impulse questions they have to be careful for, where they give you quite a lot of the pieces in our overall formula. J is equal to F net times T is equal to delta P. We have the pieces here to find delta P. We almost have the pieces here to find the F net times T, but we don't have T. And you don't need to find T. So this F net is not going to be used. This whole section of the formula is not going to be used. We just need to find the change in momentum and use that to figure out what the impulse is. Now, the momentum changed. It went from 0, because we started at rest, to m times v, m being 0.05 kilograms, v being 44. So it went from m times v, and when you do that math out, you get 2.2 Newton seconds, which again is the same as kilogram meters per second. So it's choice 2. All right, next one, we have the mass. We have the mass of the ball, the mass of the cannon. We have the force on the cannonball, and we have the time on the cannonball. It's asking us to find change in momentum. So in this part of the formula, I'm going to be using this. Change in momentum is equal to F times T. That's all about this formula, is figuring out what pieces are the ones you need to solve this one. So the force of this, we know, is 8,000 times our 0.1, newtons seconds, which is equal to 800 Newton seconds, which is also equal to 800 kilogram meters per second, which is choice 2. All right, so that's it for these. We're going to definitely be doing more practice now that we're going to be back in school. So don't worry if you don't quite get all these questions just yet. Practice is definitely going to be a big thing once we get back. But that's everything for today's video. Hope you have a good day.